All right, other more malicious fragments could also be something like missing fragments, where the attacker doesn't send one of the fragments and such, which could, the victim here could be waiting for those fragments and so forth to go on. Other things that could occur could be used like when it comes to fragmentation timeouts and so forth, if they vary between the intrusion detection system and the host. So let's say if the fragment reassembly timeout is 10 seconds at the IDS and then 20 seconds at the target system. Now what we could do is the attacker could then send the second fragment after 15 seconds of sending the first fragment. Right? What then happens is the IDS will drop the fragment as the second fragment is received after the reassembly time, but the target system will reassemble the fragments there because it had a higher rate there, right, of 20 seconds. So the attacker will then keep sending fragments with 15 seconds delay until the attack payload is then reassembled at the target system. And again, it's just a matter of playing around with that and knowing, of course, that the timings between your IDSs and your victims and so forth when it comes down to that. We also have overlapping fragments. And basically, as I mentioned before, it's called the teardrop attack. And here in IDS evasion techniques, craft a series of packets with TCP sequence numbers, right, that are going to be configured to overlap. So let's say the first packet will include 80 bytes of payload, but the second packet sequence number will be of 76 bytes after the start of the first packet. So when the target computer reassembles the TCP stream, it must decide how to handle the 4 overlapping bytes. Now some of the operating systems will basically take the original fragment with the given offset, like your XP 2003 servers, and some operating systems will take the subsequent fragment with a given offset, such as your Cisco iOS and such with that. You also have time-to-live attacks as well that you can use, and they require the attacker to have prior knowledge of the topology of the victim's network. This information can also be obtained by using tools like your trace route, for example, which gives information on the number of routers between the attacker and the victim that we have there as well. All right, so lots of cool things there when it comes down to the type of attacks that we can use against your intrusion detection systems and so forth. Again, as I mentioned here already, fragmentation-based attacks, right? So the IDS here, of course, has a different reassembly policy or reassembly timeout, as I just mentioned. So the IDS sees one, this particular may be a harmless packet, and the target sees a malicious packet. Then again, we have fragment overlapping that can occur. We have reassembly timeout that we just mentioned, and of course your time-to-live based evasion that we just mentioned as well that could be used also. So here's a little example just so you can get more of a visual on this. So let's say we have a firewall, right, that we wanted to overcome. Now the firewall's normal operation here, as you can see, it drops the packets as it does not match the allow filter, and the firewall is assigned the unauthorized state to the IP to IP pairing if it's not in the allow section. So here we get something through. It says, oh, port 21, that's not allowed. So we're going to deny port 21. So anything else that comes into play with that particular IP and so forth pairing, we're going to deny. So any packets that come in are going to be denied. Now other things is when we do the evasion technique here, let's say the first packet comes through and that we're sending a SYN packet with destination port of 25. Now 25 is allowed through the firewall, so it's going to go through. So the firewall allows the first packet into the network as the SYN packet on the allowed port 25. Now it has a fragmentation offset of 0 because it's first packet 2. It has what's called a don't fragment bit equal to 0, which means that it may fragment it. And it has a more fragment bit equal to 1, which means that more fragments are followed. Now the second packet would then come into the network as the firewall has already assigned the authorized state to the connection. Right? So the victim will then bind the interface on port 23 in this case, because if you look at packet number 2 there, the destination port is going to be 23. And what we're doing on the fragmentation offset is we're setting it to 1, which basically overrides all but the first 8 bytes of the first packet. All right, we have the don't fragment bit equal to 0, which means that it may fragment. And we have the more fragment bit equals to 0, which means that it's the last fragment. So meaning that there's no other fragments following it. And this is what it would look like. So again here coming through, and then our second one, and you can kind of maybe see where the term teardrop attack kind of comes into play. Your second packet, teardrop into where we need it. Pretty sweet little deal, right? And that's pretty straightforward. And keep in mind, these are just on ports that are allowed, right? So when we look at, hey, we're protecting our system with a firewall, just keep in mind that not all your firewall, just because you have a expensive firewall doesn't mean you're protected necessarily. All right, so, but there are definitely ways of getting around that. Of course, it takes a little bit of doing, but needless to say, there are ways to get around it. And then we have the network device bastion host, which is basically a hardened system. So if you can imagine a server, and we're taking out unnecessary accounts, unnecessary services and subsystems, we remove administrative tools, we keep it up to date with the patches and fixes and so forth, right? That's called a bastion host, also known as a lockdown system or a hardened system, right? All systems in the DMZ or demilitarized zone should be bastion host, again, to provide some form of protection with minimal rights and minimal, as you see here, right, accounts and unnecessary services and so forth, disabling and so forth with that. Okay, so definitely something to look into and to keep that in mind as you're going out there protecting your network. Now we have what's called the spyware prevention systems, which are also out there, and this one here is the intrusion spyware prevention system, which contains signatures that are specifically designed to detect and prevent commonly known spyware agents from being downloaded to any workstations on your network and so on. And it does a pretty good job on detecting what's going on and so forth. So a user basically goes to using Internet Explorer, goes to a web page, oops, something's trying to be infect itself, and of course it will block anything coming in, even if it's stealth injection. Awesome. So also when it's something what we call the phone home type scenario where someone maybe comes in and tries to go from the inside out, that will also be blocked by your spyware prevention system. Now when it comes to these circuit level gateway firewalls and so forth, keep in mind what you can do is if the firewall is only monitoring TCP handshaking of packets at the session layer of the OSI model, right? When it comes to the type of firewall that the tester is trying to traverse and so forth, would generally be what we call the circuit level gateway firewall, and that's where that kind of comes into play. Now one thing we haven't mentioned here yet either, which is what we call honeypots, and hopefully you've heard of that term before, and your honeypots are basically used to emulate services such as your mail and FTP and so forth, and capture hopefully login or actions as well from the attacker, and it basically allows us to kind of keep them in a sticky situation in a sense, right? When it comes down to finding out what the actual attacker is doing and things of that nature, right? When it comes to your intrusion detection and prevention systems, keep in mind the best practices of layered security is going to be using host-based intrusion detection and host-based intrusion prevention systems with that. The difference between that and the network-based is that your network-based are going to be obviously connected directly to the network, where your host-based are going to be connected to the machine itself, meaning it's going to be a software install on the machine and such, right? And we, of course, we have also the NIP and NID, which is your network-based intrusion detection and your network-based intrusion prevention, which we have out there as well. Pretty sweet. Okay. Let's take a peek now into the denial service side of things. And again, this is where we're going to mention a few more things. I just have a few more slides, and then we'll hop into some other topics. So here, obviously, when we look at denial service, right, it's basically trying to use up resources on the computer so it cannot respond to valid requests, such as if you're logging on to a domain controller, right, something to that effect. Right? It can also be distributed and amplified by using other systems to commit the attack. And this would be called distributed denial service. And the distributed denial service generally has what's called the master and zombies. Also, anytime we hear the term botnets, things like that comes into play. When it comes to distributed denial service, a lot of times we hear the term command and control centers and things like that, where the attacker basically has a command control center that gives instruction to all of the zombies or the botnets that will basically instruct them to attack one target and so forth. Now keep in mind when it comes to distributed denial service, you have ingress and egress filtering, which basically means that it does not allow packets in with internal source addresses or doesn't allow packets to leave with external source addresses and such. So difference your ingress and egress, inbound versus outbound. All right, and your zombie definitions here, a zombie computer, often short as zombie, is a computer attached to the internet that has been compromised by the hacker, a computer virus, or even a Trojan horse. Generally, a compromised machine is only one of many in the botnet and will be used to perform malicious tasks of one sort or another under remote direction, again using a command and control center. Right? Most owners of zombie computers are unaware that their systems is being used in this way. Because the owner tends to be unaware, these computers are metaphorically compared to zombies. All right, let's take a peek at some distributed denial service attack types and such denial service attack types that we can have. Now here, obviously we have the one called Smurf. And the Smurf attack basically has to do with ICMP packets. In this case here, the ICMP echo broadcasts, which are sent to a network with a spoofed address, where all the systems on the network segment then send an ICMP echo reply packet to the victim, which then be considered a distributed denial service attack. Main thing here about the Smurf attack is that it is using ICMP packets. It sends a ton of those out and such, and it's definitely something that is detectable using Wireshark and such, as we mentioned before. Now with Wireshark, keep in mind that TCP dump and snort, they basically all use the same packet capture utility to be able to detect what's going on in the network. And also, I failed to mention this earlier with Wireshark, is that we can actually go in and use Wireshark not just for seeing what's going on, but also for troubleshooting and so forth. So if you have any type of issues with maybe a user connecting to a website or something like that, you can actually use Wireshark for troubleshooting purposes in that sense and such as well. Now, since I mentioned it, I want to go ahead and show you real quick because I mentioned it a few slides ago, and I don't have an official slide on it. So what I'm going to do is I'm going to take you through real quickly on the scenario here when it comes to snort rules and so forth. So let me pop this in here like this, and what we're going to do is I'm going to kind of give you an idea on what happens when it comes to some of those rule sets, specifically too when it comes to snort and such. And it's actually really straightforward type of scenario. So when we're looking at, again, looking at rules, and this is again on the IDS side, we want to be able to actually identify some of those rules just by looking at some of the information. So let's say, for instance, if I have to create an alert or something, right? So I would basically put in something like, alert. And then I want to give it, in this case, I want to give it something like either TCP UDP, which I can do something like this, or I can put in UDP like that, or I can put in any, which means that it would use any. But let's, for demo purposes, use TCP. And then I want to give it a direction. In this case, I want to give it an IP address, whatever it is, 192.168, 2. I don't know, 2.2, let's do that. And then of course we give it a direction. In this particular case, I'm going to do actually this, and we're saying that an alert that looks for TCP, we look at the IP address, and then actually after that comes the port number. So the port might be something like this, 1234, or we can say any, again, any port number. And so forth. And then we're going in the direction that says, okay, if there's traffic going in from this IP address with any port number using TCP and going to this, let's maybe make it a 192.168.2.0/24, for instance, that would mean that anything basically coming from this IP address to anything on the subnet, okay, and then let's say using a specific port, like 1, 2, 3 or whatever, which is going to be for NTP, for example. Or I can do something like 111 or whatnot, whatever it is. And then basically we want to go in and maybe put something like content, colon, and then we give it the content, whatever the content is. And this is basically going to be whatever the particular, what we call the payload and such. Something like this possibly, right? So if it has that in the contents or what we call the payload, right, then I want you to then go out there and give us a message. And the message will, will basically say something like external mount d-access or something like that. Okay, and it would look something like this. Right, of course that would be all in one shot and so forth, but overall what you need to be able to do is identify, you know, kind of the gist of it. So we have the alert. Obviously it says that we're doing an alert. We're saying what we're looking for, either UDP or TCP or whatnot. IP address. Now, of course, this could have been a /24 as well or whatever. But let's just say from this target, we're using any port number going in this direction, right? So meaning that anything in the internal network on port 111 and it has the content of these hexadecimal values within the content itself, which is also referred to as the payload, then I want you to send up a message which says external mount D access. Right? And that's basically how we identify some of these snort rules when it comes down to that. Anyway, so that was kind of the snort scenario there on the snort rules. Those are obviously going to be the same type of scenario when it comes to any of your other intrusion detection. A lot of them are going to be very similar to that when it comes down to that. Okay. Now, other things here is the Fraggle attack. Right? It's basically the same as the Smurf attack, but it uses UDP instead of ICMP protocol. Right? So it uses UDP packets and just floods the network with that. Remember, you can use something like Wireshark to identify these very easily. Now, we also have the SYN flood attack, which sends multiple SYN packets. And again, the main thing here with the SYN packets is that's important is that we basically send out a large number of SYN packets out there, right, which appears on the network without the corresponding reply packets and such. Now, with that in mind, too, is you know, when we're talking about replying and so forth, just know that when it comes to like a spoofed IP address, for instance, right, that the server will not be able to actually complete the three-way handshake because it actually replies back to the spoofed IP address that we might be sending out and so forth. So keep in mind when we're trying to you know, send packets across. In this case here, since we talked about spoofing earlier in the module here, is that when we're spoofing an IP address, we can't complete the three-way handshake properly because again we can't transfer data, as I should maybe say, which means because, you know, if you have a spoofed IP, you know, spoofed IP, it's sending it to an IP address that's not really there. So you can't do any data transfer along with that and so forth with that, right? So, but anyhow, remember that the SYN flood requires SYN go out, SYN acknowledgements, but no acknowledgement to finish up the three-way handshake. So in essence, it's a two-way handshake. And we saw the teardrop attack already where we're sending multiple SYN packets, again changing the fragment offset a little bit to then overwrite the first packet and so forth with that. Okay? And that's where that kind of all comes into play. And just know the terms may be utilized at some point in time depending on your network and so forth. And yeah, it's one of those cool things. Now, another thing that I may not mention with the distributed denial service attacks, remember I mentioned botnets, which are basically your zombies and so forth, and those can also be managed through IRC as well, in case I hadn't mentioned that before, and such. So those are definitely some of the things you might want to take into consideration when it comes to some of those type of things and some of that information as we talked about. Again, it's pretty cool, pretty straightforward, and just know that we do have the ability to bypass your IDSs and your firewalls just again by looking at some of the standard and of course the type of attacks that allows us to bypass that and such as well. So pretty straightforward, pretty cool, and such as well. Okay. I believe that would be the gist of it on this particular section, and let's see if we can get into some other scenarios, such as viruses and worms and such. So let's see if we can get into some of that and get you guys into the virus mode.